right? So we'll finish the recovery and do some past papers, and we want to move on to the distributed databases. Okay, I shared the distributed database note also to the WhatsApp group. It's not in the Google Classroom, but I just share it with the WhatsApp group. Okay. Right, so let's finish the recovery and do some past paper questions, and then we will move on to the distributed databases. Okay. Right, so recovery, I explain you how the recovery is done. So you have to go through the transaction log and make sure that those successful transactions are redo, and unsuccessful, or if the transaction is halfway, we have to make sure that we undo those transactions. Okay, so committed transactions we can redo, uncommitted transaction we have to undo. And also the last save point is the reference point, because at that save point anyway things are flushed. Okay, and there's a very special case as well, that is, say if transaction 1 did some change to a value, right, but it is never committed, so that means that value is going to be rolled back. If transaction 2 has read that value, that written value is read by transaction 2 and transaction 2 is committed before the failure, we have to make sure that we roll back the transaction 2 also. Okay, so that is a very important thing you have to remember. So I'm repeating it, because most of the time we lost this particular task. If transaction 1 has done some change and later it never got a chance to commit before the crash, but the transaction 2 read that value and transaction 2 commit. But anyway, when transaction 1 we have to roll back, then this value is wrong. So therefore we have to make sure that transaction 2 is also rolled back. Okay. So far they have not asked that kind of questions, but that is something very tricky scenario where the examiner can check. Okay. Right. And also in general, we assume that it is still and deferred update. Okay, still, and also it is no force. Okay, so that is where we have to do both redo and undo. Otherwise, we have less work to do. Let's assume that it is still, that is, there's a possibility of uncommitted things flush into the database, and also committed things not flush into the database. So that is what is meant by still and no force. Okay. Right. So let's straight away do some past paper questions now. Okay. And some of the questions are a little bit fussy and the answers are fussy, but most of the recovery questions are very straightforward. Right. So let's take past paper questions one by one and finish it. Okay. If I have done the question last week, just let me know. Okay, I did double check. So just immediately tell me that okay, we did that. Okay. Because I'm having so many classes, sometimes I can't keep track of each and every question. Right. So let's start with 2020 paper. At 2020 paper, we completely finish it right now. Okay, I think we have to do the transaction question. We have to do the recovery question, right? Other things we did. We did this part, right? And so we did this part. Did we do the A part and B part today? Yes or no? Explain the difference between serial schedule and serializable schedule using an appropriate example, so that you should be able to explain. Serial schedule means you do one after the other. Serializable schedule means we are mixing, still it is equivalent to a serial schedule. Right? So you have to give an example. There are no cycles. You have to give an example, any examples you can think of, but make sure though you are mixing it. Now here you can see 0, 0, 0, then 1, 1, 1, then 2, 2, 2, 2. It's a serial schedule. But here mix 0, 1, 3, 1, 1, 1, 2, 2, blah, blah, blah. Right? You can give any example, but make sure that example is a valid conflict serializable schedule. Okay. Just do some changes here and there, just a few changes, but again double check whether it is correct. Okay, it is correct. That means it is conflict serialized. That means no cycles. Okay. So if you just randomly write a schedule and if it has cycles, the examiner is not going to give you the marks. Okay. Right. So second part. Consider the following schedule created using 6 transactions. Is this schedule conflict serializable? Give reasons. If the above schedule is serializable, determine equivalent serial schedule. I hope now you should be able to do it. We did a lot of these kind of questions. If you find the answer is not correct or you are not getting the correct answer, just let me know. I will do it some other day. But I hope because we did this kind of questions, plenty of these kind of questions. Okay. Right. So this one we did today itself. Right. So D part is the final part. Yes, then that's all. Right. So let's do the D part. Deferred update is a technique. Deferred update means we don't immediately update when a commit is done. So after commit also sometimes it is not flush. We are just waiting for some other opportunity. That is what is meant by deferred update. Okay. It's a technique used for database recovery from non-catastrophic transaction failures. Actually, deferred update is not a database recovery technique. It's a database transaction technique. Okay. Explain briefly the reasons for using no undo redo algorithm in deferred updates. Okay. So now in deferred update, it's only redo. We don't do undo. Why? That is a question. So deferred update means, remember the 4 combination? Steal, no steal, immediate and deferred update. Okay, in deferred update, we do not update or flush the values immediately after commit. Okay, immediately after commit. So therefore, there is a possibility that the transaction is committed before the failure. Still, we may not have flush it. Right? We may not have flush it. So therefore, we have to do the redo, because there can be committed transactions which are not flush. So therefore we have to do redo. So there it says deferred update. So deferred update means there's no, it's not steal, it's no steal, right? Otherwise it has to say no steal and deferred update, right? So they say it's just deferred update. That means we are not doing do the stealing. Stealing means we are not flushing uncommitted transactions. We flush only committed transactions. So therefore, we don't have to do undo. Right? We don't have to do undo. So therefore, we can do no undo redo algorithm when we are only having the deferred update. No stealing. Okay. Likewise, you have to explain it. Right? The database is never updated until after the transaction commits, and there is never a need to undo any operations. You can see. So there is no steal. There is no steal activities. We never update until it's commit, until the transaction is commit. So that means we are not going for steal. So deferred update means no steal deferred update. Okay. Otherwise, it will say steal and deferred update. So that means no steal. No steal means we are not flushing unless it is committed. So therefore, we don't have to do undo, because undo has to be done if we have flushed it before commit things. So therefore, we don't have to do that. But since we are doing deferred update, maybe committed things may not have flush. So therefore, we have to do the redo. Right? You don't have to do undo, but you have to do the redo. Okay. Redo is needed in the case of failure after transaction commits, but before all these changes are recorded in the database. So that means before it is flushed, the database may crash. Okay. In this case, the transaction operations are redone using the log entries. So you just have to do the redo. You don't have to do the undo. So any questions? So because you must not have any doubt about this. I told you there are 4 possibilities: steal, unsteal, immediate, deferred update. So we need to do both redo and undo when it is steal and deferred update. Right? Steal and deferred update. So this is, it says only deferred update. So therefore you just have to do the undo, redo, not the undo. Undo has to be done if you have done the steal. Right. Second part. Consider the database log given below at the point of system crash. So this is system crash. So basically, no log entries means the system has crashed. Because once the system crashed, no log entries. Now then someone will ask, if the system has crashed, how do you find the log entries? I assume that the log entries are in the different disks, or it is not a disk failure, rather some other failure. Okay, so most of the time your transaction logs are in one disk, your database is in another disk. So therefore, even though the database disk failed, the transaction log disk will be there. Or maybe the failure is due to some other reason. Still your transaction log is available. Okay. So therefore, your last entry will be the system crash, because afterwards you can't see it. Or otherwise, your question says the system crash at, say, now line number 13 or line number 6. So that kind of questions also they give. But here they say, it specifically say this is where the system has crashed. So that means that this is the last log entry. Okay. Right. Assuming that the deferred update protocol is used for recovery. So again, it is deferred update. Okay. So deferred update means usually you have to do only redo. You don't have to do undo. Okay. So that is deferred update and no steal. Identify what will happen to the transaction T1 to T4 and what will be the values of the data items A, B, C, D, E, F on disk after recovery. So remember this, here you don't have any optional questions. Every question you have to do. Okay, right. So what will happen to the transaction T1 to T4 and what will happen? Now this is the first part of the question. Identify what will happen to transaction T1 to T4. Second part, and what will be the values of the data items A, B, C, D, E, F after recovery. After recovery. And this is the format: transaction ID, data item, new value, old value. Okay. Now let's do this. Now we also have to analyze. Okay. Right. So transaction 1 has happened. So first mark the checkpoints. Right. So there's a checkpoint right here. There's a checkpoint right here. So that means there's a flush here. Okay. That is the last checkpoint. If there are other checkpoints, you don't worry. What we're interested is the last checkpoint. Then check which transactions has committed. So transaction 1 committed. So that means transaction 1 is committed. Okay. Transaction 2. So start transaction 2. It looks like transaction 2 is never committed. Committed. So transaction 2 is also okay. Transaction 3 is also committed. Right? Transaction 3 is also committed. So transaction 4, you start transaction 4, but it has not committed. So that means transaction 4 is not committed, but other 3 transactions are committed. Right? So when you commit, we flush it because this is deferred update. Sorry, without committing, we don't update. Okay, without committing, we don't flush, but there's a possibility that the committed things are not flushed. Okay, committed things are not flushed. So that is what is my deferred update. We defer or we postpone updates, even though transaction is committed. But we never steal. Steal means without committing, we don't update. For example, here, transaction 1 update B from 50 to 200. So we don't do this change to the database until it is committed. So that is what is mean by no steal. So deferred update means no steal, deferred update. If it is steal, they have to set it. Okay, so that means T1, T2, T3 is done. T4 is not finished. So therefore, definitely we have to undo T4. Undo T4. Right. So where do we start transaction 4? Here. Right here. Actually, we don't have to undo T4 as well, because here we don't flush unless committed. So T4 has not committed. So therefore, actually we don't have to undo T4 as well. Okay. We don't have to undo T4 as well. But first we have to identify that T1, T2, because the question asks what happens to the transaction. What will happen to the transaction T1 to T4? So T1, T2, T3 has committed. Okay, before the crash, but T4 has not committed. So that is the answer for question part 1. Okay, let's see the answer. Right, transaction 1. Okay, so they have even explained the reasons also. Okay, right. So T1. So they have expected a little bit more details. Transaction T1 commits here. So that means you don't have to redo. Right? You don't have to redo. Now remember, we have to redo, but no undo in deferred update. So anyway, transaction 1 we don't have to redo also, because transaction 1 is already committed. And there's a checkpoints also. Before the checkpoints commit means at the checkpoint, definitely it is. So in deferred update anyway, at the checkpoint we flush. So therefore transaction 1 is already flushed. Okay, so therefore we don't have to redo the transaction 1. Okay. What about transaction 2? Transaction 2 commits here. Transaction 3 commits here. So therefore, it's deferred update. Maybe we are waiting for another checkpoint to do the flushing. So therefore, we have to redo transaction 2 and transaction 3. Right? Transaction 2 and transaction 3, we may have to, okay, redo. So T2 and T3 need to redo. Okay. Then what about transaction 4? Transaction 4 is not committed, right? Not committed. But this is deferred update. So therefore, usually we don't have to do anything. Usually we have to undo. Right? Remember, these things we have to undo if it is steal. But question doesn't say anything about stealing. So therefore, we don't have to do undo, but I don't know. If it is normal, deferred update and steal, anyway, we have to undo transaction 4. There's a possibility of these things are flush. Because if it is steal, you can flush it without committing. Okay, so since they are not mentioning about the steal, they just say deferred update, I will say nothing to do, because it is only deferred update. Okay, but these two we have to redo. These two we have to redo. Okay, so let's see what is the answer from the examiner. Transaction 1, no need to redo since it has committed before the last checkpoint. That last checkpoint, definitely it is flush now. Okay. Transaction 2 and transaction 3 will be redone. Right? Yes, because they are committed after the checkpoint. So deferred update means they may not be immediately updated to the database. That is also correct. Transaction 4. is ignored since it has not reached until the commit point and no undo is required in deferred update protocol. Now you can see, if it is deferred update protocol, you don't have to do undo because deferred update means only issue is deferred update. You don't have the still issue. So therefore, without committing, these things are not flush. Because deferred update means basically deferred update and no still. So in no still scenario, these things are not yet written before crashing. So therefore, you don't have to do anything. Usually, yes, we have to undo. But here, you don't have to undo because this is only deferred update issue is there. Still issue is not there. Right. Any questions? Right. So required in deferred update protocol. No undo is required because it's deferred update. Any questions? So don't worry, yeah. If you have even a slightest question, doubt, you have to ask. There's nothing called stupid questions, right? Every question is a valid question.
So can you explain again undo and redo?
Yes. So remember, there are four possibilities. We have steal, no steal, deferred update, and immediate update. Those are the four possibilities. Okay. Let's get back to our note. Right. So those are the four possibilities. Steal, no steal, okay, force, no force. Sorry, I think I used the wrong wording. So deferred update means, so here you have to look at it. I think this wording is a little bit confusing. And forget about these words. So steal means you can commit before, you can flush before committing. No steal means you don't flush before committing. Okay. Force means immediately after commit, you write it. No force means when it is committed, still you may not flush it. You are waiting for something else. Okay. Right. So force means you commit means at the commit point you flush it. No force means you may not commit it even after committing. Okay. So therefore there are four possibilities. Okay, four possibilities. Steal, no force. So that means you have to do both undo and redo. Steal means you have flush uncommitted things. No force means you have not flush committed things because you are just waiting for some other time. Then steal force. So now the force means when a commit is done, you immediately flush it. So therefore you don't have to do undo. You don't have to do undo, but steal is done. That is, before committing, you may have committed things. I think, yeah, just give me 1 minute. I think this wording is wrong. Steal force. Yes, because we are doing the stealing, those things we have to undo. Yes, correct. Right? Because we are stealing, that is before committing, sometimes we flush it. So therefore, those things we have to undo. But whenever commit is happened, immediately we write it. So therefore, you don't have to redo. If it is committed, it is in the files. Okay. So then no steal, no force. Since you are doing no steal, right? You don't have to undo. Okay. But you are not forcing it. At the commit point, sometimes you don't flush it. So therefore, you may have to do the redo. If no force and no steal and force, no steal means without committing, you don't flush it. So therefore, you don't have to undo. Force means immediately when commit happens, you flush it. So therefore, you don't have to redo. If your transaction log says commit, it is in the file. You don't have to redo it. Okay, so those are the 4 possibilities. And this is where you have both redo and undo to done. Right? Undo and redo, because you are stealing as well as you are no forcing. Okay. And this is where you don't have to do anything. You don't have to do anything, because if it is committed, anyway it is there. If it is not committed, anyway it is not there. Okay. If it is not there. So then all the uncommitted transactions are, nothing is written to the file. If it is a committed transaction, definitely it is there, even though you have a save point or not. Right? You are not waiting for save point to flush it when you have force. Okay, so this is where you have nothing to do. Just you have to identify which transactions are success, which transactions are not success. So not success transactions, someone has to again redo it manually or whatever. Okay, so that is the idea. Okay, so now in the question they say deferred update strategy. Right? So deferred update strategy is used when you have steal but no force. Sorry, not steal but no force. It is done when how do you call it? So this is the wording is little bit confusing. What is the question? Is yeah, no undo deferred update, right? Yeah. Explain brief the reason for no undo redo algorithm in deferred update. No undo redo. So question has mentioned no undo redo. Okay. So when it comes to no undo redo, that means you don't have to undo, but you have to redo. So why you don't have to undo? That means without committing, you are not flushing. That means you are not stealing. Right? You are not. So no undo is done when no steal. Redo is done when it is no force. If it is force, you don't have to do redo. The commit means it is there. You don't have to worry. So that means redo is needed means it is no force. Okay. So this situation is called deferred update situation. That is how it is called. Right? Deferred update situation. No steal, no force. Okay. So no steal is good one for recovery, but no force is a bad guy for recovery. So therefore, we have to do redo. Since you are not doing stealing, you don't have to do undo. Okay, so this table is there. Say force, no force, deferred, update. There's a table. That table I have not included in your note. Right, you can see here. Where is it? Which slide is that? This one. Right. So deferred update means no undo, redo is needed. Right. Undo is not needed, redo is needed. Okay. So that is called redo. If redo is needed and undo is not needed, we say we have to do a deferred update way. So that is actually, those are two different concepts. Actually, our note is a little bit confusing. Actually, what I should have mentioned is this note, this diagram. So if it is no undo is not needed and redo is needed, we say deferred update. Okay. If both undo and redo is needed, we say immediate update. If undo is needed but no redo is needed, we say force immediate update. If no redo and no undo is needed, we say shadowing. Okay, shadowing. So here it says deferred update. So deferred update means no undo but redo is needed. So no undo means there is no stealing. Redo is needed means it is no force. So that is how you get it. Okay. So first from this table, you have to understand that deferred, because question says deferred update. Deferred updates means no undo redo. Okay. So then if they say no undo redo, no undo means no stealing. Right? Because stealing one are the things that you have to undo. But redo is needed means you go for the no force. If it is no force, you have to redo. Because if it is force, at commit, it is flush. So that is how you have to get it. Okay. So anyway, I will add this diagram also to your notes. Then it will be less confusing. Okay. Right. So now it should be much more clear to you. Okay. Right. So deferred update means no undo. Actually, you have to memorize this table actually. Okay. So therefore, now we know that it is a no undo redo situation. Right. So if it is a no undo redo situation, because the question says, right, because the question says it's a no undo redo situation, right, no undo redo situation, we know that. So what we can get it from there is, it is no undo means no steal, redo is needed means it is no force. If it is force, you don't have to do redo, because when the commit, it's already there. But now there's a possibility of committed things are not written to the files. Okay. Right. Now I hope that is clear. I will post that, pick that to the, for the time being, I will put it into the WhatsApp group, because this actually this table is one we have to use. It is unfortunately not mentioned in your note.
So what about semester 3 notes?
Which one?
Do they have these notes?
Semester 3, they don't have semester 3, they don't have even login and timestamp. Right? They don't have recovery. They have only up to the scheduling, complete and view scheduling. They don't have anything beyond that. So their syllabus is smaller. Okay. So therefore, you can't get it from semester 3 note. Semester 3 note has only half of your syllabus. Right. Now let's move on. Right. Now let's move on. Now you know that it is, we don't have to do redo, but we have to do undo, because it is deferred update. Okay. Because deferred update means no steal, no force. Right. Now let's look at this one again. Right. Now remember, no steal, no force. That is the database setting, right? No steal, no force. Okay, so that is something you have to remember, because the question says like that: no steal, no force. So that means we have to do redo. We have to do redo, but no undo. No undo. So undo has to be done if there are steal. Right. Now, then you have to look at these transactions. Okay. So this is where the checkpoints. So since no force, these committed things will be flush only at checkpoint, or there's a possibility that committed things are not flush. That is what is meant by no force. Okay, but you don't have to worry. At this transaction, one has committed here. It may not be immediately flush, but anyway, at the checkpoint, it is flush. So that is why we say T1, you don't have to do anything. So nothing to do, because though it is no force, at the checkpoint, it is flush. So therefore, you don't have to do anything for the transaction 1. Okay, because transaction 1 is committed before the checkpoints. But transaction 2 is committed. Transaction 3 is committed. But there's no checkpoints after that. Therefore, there's a possibility that these 2 transaction related data is not yet committed because it is no force. So therefore, we have to redo those. So transaction 2 and transaction 3, we need to redo. Okay. Then what about the transaction 4? Transaction 4 starts here. Transaction 4 starts here after checkpoints and it crashed. Remember, we are running on no steal setting. In no steal, if it is until it is committed, we are not going to flush it. Right? Until it is committed. Even in a checkpoint, it is not flush until it is committed. Okay. So therefore, we don't have to worry about the transaction 4 in these settings. Usually we have to undo if it is steal, but because this is no steal, you don't have to worry about the transaction 4 related data, because nothing to do, right? Nothing to do, because it is not going to be steal. Right? This is no steal situation. So therefore, without committing, these things are not flush. So therefore, again, nothing to do. So only we have to redo related to T2 and T3. Okay. So T2 and T3 will be redone. T1, no need to redo since it has committed before the checkpoints, and the checkpoint it is now already flush. T4 is ignored since it is reached. It has not reached until the commit point, and no undo is required in deferred update protocol. In deferred update protocol, since we are not doing stealing, you don't have to do redo. Sorry, you don't have to do the undo. Okay, you don't have to do the undo. So any questions now? Is it better or still you have confusions? I think this table will release most of the confusions. Okay. Right. So the next part. What will be the values of the data items A, B, C, D, E, and F on disk after recovery? Now, after the recovery, what are the values of A, B, C, D, E, and F? Okay. Right. So let's do it. Say this is my A, this is my B, this is my C, this is my D, this is my E, and this is my F. Right. Now remember, A is committed, and also it is checkpoint, so it's flush. So therefore, anyway, we have to think about those values also. Now A is initially 100. This is old and this is new. A is initially 100. Here A has become 500. B initially 50. At this point, it has become 200 and it is committed, right? Commit and flush. Commit is not good enough. It has to be flush because this is no force. So because of the checkpoint, we are flushing. We are just checking what is going to happen. Anyway, you don't have to do anything for these things during recovery. This is not recovery question. This is they are asking just the final values. Right? In the recovery, you don't have to do anything about that because recovery has to be done only after checkpoint. Right. So C. Now this is done. This is done. Now A is changed from 500 to now you can see 500 to 750. Now it is 750. Now T2. Right, T2 anyway we are going to redo because T2 has committed. We can finish it. Okay, so therefore let's take this, because after the recovery, T2, all those things will be reflected. Okay, so T2 is doing 20 become 80, right? 20 become 80. Then T3, anyway, T3 is also we are going to commit, right? We are going to commit. So therefore, let's take that also. So T3, we are going to change C from 80 to 120, 80 to 120. Again T3, D from 20 to 50. And again T3, sorry, T2 we are going to redo anyway. T2, E from 40 to 60. 40 to 60. Okay. Now again T2, we are changing C from 90 to 120. So what is that? 80 to 120. Sorry, 120 to 90. Sorry, 120 to 90. So that is 120 to 90. Okay. So old value, new value. Now transaction 2 and 4 anyway we are going to, transaction 2 and 3 we are anyway going to commit or redo. So that is why we took those things. Right now we are not going to, right, we are not going to do these things, the transaction 4 related things. Why? Transaction 4 related things are not committed. So if it is not committed, we are not going to do that. We are not going to do that. But anyway, we have to look at the values. Right? We look at the values. The transaction 4, E 10 to 30. Sorry, 10 to 30. Or something else. Sorry, F. Right? Transaction 4. Anyway, transaction 4 is not going to effect because transaction 4 is incomplete transaction. So therefore, this change is not going to be reflected. Okay. So that, but according to the transaction 4, this activity, we can see that old value is 10. Old value of F is 10. So therefore, it will be there. It is not going to be changed to 30 because this is not flushed to the database, and therefore we are not worried about that, right? And we are not worried about that. We are not worried about that. So E will remain 60, right? And B will remain 200. B will remain 200 because these two transactions are ignored because it is no still. Anyway, the database may not have flush it, and therefore we don't have to worry about those things. And therefore, final state also we don't have to worry about. We don't have to consider these changes because these changes are never happen. And we are not also going to redo it because it's an incomplete transaction. Incomplete transaction එකක් අපිට redo කරන්න බෑනේ. එතකොට අතරමඟ අවස්ථාව නවත්තන්න ඕනේ. මෙතන undo කරන්න ඕනේ නෑ. මොකද මේක no steal හම්බ. So therefore the final states will be 750, 200, 90, 50, 60, 10. But 750, 200, 90, 750, 290, 50, 60, 10. 50, 60, 10, correct. Right? 750, 290, 50, 60, 10. So that those are the final values. Right? So that is how you do it. Any questions? Any questions? Still, if you have any confused, actually that question is good one because you asked that question. Because I know that this table is there, but unfortunately, I have not added it to the your note. So this table must be your starting point. Okay. So because of that question, I managed to get it. Anyway, I will add it to the note as well. Okay. Anything else? No. Right. So that is 2020 paper. Okay. So the 2019 paper. Is it 2019 paper? Yes. It's 19 paper. 20 paper anyway we did, right? Is this 2020 paper? Yes, 2020 did we do? No, this is 2020 paper, right? Yes, so this is 2020 paper. Then this is 2019 paper. Let's see the 2019 paper then. Right. So did we do the 2019 question part A last time? Explain the difference between මේක දැන් කතා කරන්නේ. මම දෙකක් කලවම් කරගෙන තියෙනවා. So anyway, we discussed this one. Yeah, we discussed this one. Oh, I'm really confused. It looks the same question is there in both 19 and 20, right? So exact same question. That is why I'm getting confused. It looks like exact same question is in 19 and 20, right? So this is, yeah, exact. So no, the question is pretty much the same. Only thing is the data is wrong. Data is different, right? 50, 30, 500, 100, right? Transaction 1, B, 250, 40, 0. Only thing is the data is different, okay? Data is different. Right, so that is the difference, okay? That is the difference. So that is why I got confused because it looks the same, pretty much the same thing. But we did this 2019 paper, okay? So shall we do the 2020 paper then? What is the question they ask? Yeah, E part. Or shall we do the entire question? Okay, we'll do the entire question. Okay, I hope we haven't done it. A part, anyway, you can do it. What is atomicity? What is consistency? What is isolation? What is durability? We discussed that. Right. So do the B part. Transaction T1, T2, T3 are associated with an airline reservation system. If we did this previous day, just let me know. The number of seats in flights UL 203, UL 405 and 125 are 125 and 300 respectively. And initially there are no bookings for the flights. Question. If the operations are interleaved as given above, identify the final results of transaction 3 and the problem associated with this schedule. Briefly explain the problem and suggest an appropriate solution. Now do it because I gave you enough time. I do it. Exam without with exam pressure and everything. So you have to prepare and go. Transaction T1, T2 and T3 are associated with an airline reservation system. This is transaction 1, transaction 2, transaction 3. Again read it. The number of seats in flights UL 203. So you can see they are referring to UL 203. So UL 203, there are 125 seats initially. And UL 405, there are initially 300 seats. Okay. Initially, there are no bookings for these flights. No bookings, 0 bookings. Okay. Right. Now, most probably these are some booking transactions. Okay. Booking transactions. Right. So, transaction 1, read seats from UL 230. 3, book 4 seats. Write the number of seats. Okay. That means you have to update the number of seats available. Initially, UL 203 has 125. After booking 4 seats, it will be updated to 121. Okay. T2, read seats from UL 405. book 15 seats. That means you have to decrement by 15 and write. The transaction 3, it's not a booking one. It's a sort of a taking the report. Read seats from UL 203, total equal UL 203 seats. Read seats from UL 405. The total is that total plus. So it is calculating total number of available seats. So it's a different transaction. It's a report taking transaction. Okay. Now question. If the operations are interleaved as given above, you can see interleaved. So you do these things, then you do this, then you do this, then you do this. Actually, these two are pretty much like a serial, but this guy is in between these guys too. These things are happening in this order. Okay. Therefore, it is not a serial schedule, definitely. If the operations are interleaved as given above, identify the final results of T3. Identify the final results of transaction 3. So what are the outcome? Or what is the total you are getting? Okay, what is the total you are getting? So that is question 1. Final result of T3 and problems associated with this schedule. So it says this schedule has an issue. What is the problem? Briefly explain the problem and suggest an appropriate solution. So you have to mention this problem and you have to briefly explain it and you have to come up with a solution to that problem as well. Now do it. Now I hope you have a better idea. Okay, right. So let's see. So any question, any answer? If the operations are interleaved as given above, identify the final result of T3. Let's do that one first. Right, final result of T3. Read seats from UL 203. So it will be 125. So therefore your total is now 125. Okay. Because UL 203 has 125. Now this read from UL 203. You book 4 seats. So that they are not directly mentioning because this is final year. They assume that you will understand this. When 4 seats are booked, you have to subtract that. So therefore, this will be 120, 121, and write it. Now this one, because we are going through the schedule. Read seat from UL 405, which is 300. Book 15 seats and write. So that means 300 minus 15. It has to be 285. Okay. Now read seats from UL 405. Right. Now you are reading from UL 405. So UL 405 has now 285 seats. Right. So now you're adding that to that, the previous total. So therefore your final total is 5 plus 5, 10, 11, 410 seats. Right. 410 seats. So what it try to find out? It try to find out, I think, what is the available number of seats. Right? What is the available number of seats? But in reality, right, in reality, available number of seats must be not 410. It must be 5 plus 1 is 6, 8 plus 2 is 10, 406. Actually, the available number of seats right now is 406 because 4 seats subtracted from this one, 15 seats subtracted from this one. But what your report says is 410 seats are available. 410 seats are available. So why is that happen? Because you take UL 203 count before this subtraction. So that is the issue. That is the issue. So what is this issue is called? Now first answer is 410. Okay. 410. 410. Okay. So how do you call this part? So this is sort of an inconsistent summary, or when you read the value twice, it is giving different things, right? It's something like that. Or because here you are reading the seeds, but here you are reading some other record, right? Other record, but report is wrong now. Report is wrong. So this is happening after you take that. This time, after this is done, you are taking that. How do you call that issue? This is written one, you are reading. This is already written, now you are reading, right? But this is after reading, it's written. Is it a right read issue? Right read. So this is written and you are now reading. So that is called what? If you are reading something written, dirty read, right? Is it dirty read? The dirty value is you are reading. Here you are not reading a dirty value. Either you should have done both of this before this, or you should have done this one and this one at the here at the end. Right? So either both should have done before these two, or these two have done after doing this. Okay. How I don't know. It looks like this is a dirty read. Dirty read. Or is it inconsistent summary? Either dirty read or inconsistent summary. I'm not very sure which one is the prominent one. Both issues are there, but it's not inconsistent summary also because you are reading one record only once. This is you are reading another record. So therefore I will say dirty read. Okay. What is the answer? Due to they have taken it as inconsistent summary. Okay. Data incorrect summary problem occurs. Right. So I thought they will take it as a dirty read, but actually this is not really inconsistent summary as well, because these records are from different things. Okay, different things. But anyway, it's little bit of inconsistent summary is also there. Usually inconsistent summary means you read the value once and you read the same value again. But this is actually two different records. Right? Two different records. So therefore, this is, I don't 100% agree that this is inconsistent summary. But the way the examiner has presented this, we can see that he is looking for inconsistent summary issue, right? Inconsistent summary issue, but I don't think that this is the perfect sort of example for this one, okay? Because they are two different records. Perfectly inconsistent summary means when you read the same record twice, it has been changed. Actually, these are not same records, okay? So anyway, examiner has taken it as inconsistent summary. Okay. Right. So then you have to explain it. This problem occurs. Now he is explaining the inconsistent summary issue. This problem occurs when transaction is calculating summary function on a particular data item, while other transactions are updating those data items. Okay. Those data items. Transaction performing the calculation may read some data items before they are updated and others after. Actually, these updates and other things are happening for different record. Okay, but anyway, for your summary report, both are considered. So therefore, even we can take it as inconsistent summary as well. Okay, right. So solution is, so now they ask what is the solution also, right? Suggest an appropriate solution. So you have to go for a sort of a serializable schedule, because this is not a serializable schedule, right? This is not a serializable schedule. That is the issue, right? You have to go for a serializable schedule. Now let's see whether this is not a serializable schedule. So it has to be, right? That is why we have this issue. So transaction 3 is reading this value, which is writing to this value. So therefore T3 to T1 is there, because this is reading the UL 203 count. This is write in the UL 203 count. So that is read and write. So this way. Now these two are independent because they are different counts. What about these two? Now this is writing to transaction 2. This is reading from reading that value. So therefore it is T2 to T3. I think no cycles, right? So T3 to T1 is there. Then T2 to T3 is there. T2 to T3 is there. It looks like it is not cyclic anyway, right? Because T3 to T1 is there. T3 to T1 is there. So T2 to T3 to T1 is there. T2 to T3 is there, correct, right? So it looks like no cycles anyway. Because they are two different data. By the way, it's a little bit confusing question anyway, but anyway, there's an issue here. This report is wrong anyway. But no cycles are also there. T3 to T1, T2 to T, there's no issue, no connection here because there are two different reports. Right C, no, right C, that report. Anyway, so cycles are not there, but there's issue. Definitely there's issue. Okay. Because this report is wrong. Anyway, so it's a little bit tricky question. Right, next one, consider the two schedules S1 and S2. S1 and maybe later S2. Yes, S1 and S2. And determine if they conflict serializable or not. If the schedule is serializable, determine equivalent serial schedule. If it is not, briefly explain the reason, clearly identifying the data items that cause the conflict. Did we do this? I think no, right? So 2020 paper, no, right? So quickly do this. Quickly do this because this is the last year paper. It's very important for us. Do this and also do the second one also. So that means you just have to draw the precedence graph. That's it. And see whether there are cycles. Okay, so let's do it. Transaction 2, transaction 3, transaction 1. Okay. So transaction 1, transaction 2, transaction 3. Transaction 2, read by. Transaction 2, write by. Transaction 3, read by. Transaction 1, read X. When you put it like this, it's easier. Transaction 4 is also there. Transaction 4, write Z. Transaction 1, write X. Transaction 3, write Y. Transaction 2, read X. Transaction 1, read Y. Transaction 1, write Y. That's it. Now let's see this. Read, write, same table, same transaction. Write and read, conflict is there, possible conflict. Then next, first time it is used. He said first time. This is within the same transaction, no issue. Why? Anyway, there's a conflict, but anyway, we have already mentioned it, right? T2 to T3. Therefore, you don't have to mention it. If you want, you can just mention it, but anyway, we have seen it. Then we have XX, okay, there's conflict. Then again, Y. So there's a conflict between T2 and T1. And also there's a conflict between T3 and T1. And of course, this is the same thing. Okay. Now let's see the precedence graph. T2 to T3. T2 to T3. Again, T2 to T3. T1 to T2. T1 to T2. And T3 to T1. Cycles are there. You can see cycles are there. So therefore, this is not a serializable schedule. T1, T2, 3, again T3 to T1. So this is not a serializable schedule. Right? Say T1, T2, T3, and there's T3 to T1. 2 to 1 see the 2 to 1 is also there. Yes, 2 to 1 is also there. There's another issue also. I didn't see that. Right? T2 to T1. So many cycles. Right? So many cycles. So actually there are 2 cycles. This cycle and this cycle. Right? So therefore it's not serializable. It's not conflict serializable. Okay. Right. So precedence graph contains cycles. Therefore schedule is not conflict serializable. Right? So you get 2 marks for that and 4 marks. Precedence graph 3 marks. Okay. Altogether 5 marks. Right. So let's do the second one. That is first one. Right. So that is the second one. Transaction 1, 2, 3, 1, 2, 3, only 3. Read 3Y, read 3Z, read 1X, write 1X, write 3Y, read 2Z, read 1Y, read 2X, write 1Y, write 2X. Now let's see. This is read 2Z. Read 3Z. Right. Y, Z, X, no issue yet. Again, Y from the same transaction. Z, it's okay because it's a read is not a conflict. Remember, read is not a conflict. No issue. Then Y, this is write Y, read Y. So there's conflict. So this is X, yes, write X, read X, conflict. Then write Y, write Y, write Y. Anyway, 3 to 1 we have already mentioned. So I'm not writing it again because 3 to 1 we have already mentioned. And write text. Anyway, write text to read text is already mentioned. Okay, already mentioned. So therefore, those conflicts are already mentioned. So that's it, right? So that means there's no cycle. T3 to T1 and T1 to T2. So no cycles, and it is going to equivalent to the T3, T1, T2 serial schedule. T3, T1, T2 serial schedule.
So there is a write text to write text.
Where?
T1 to T2.
T1 to T2. T1 to T2. Write text to write. No, I have already mentioned T1 to T2, right?
T1 to T3.
T1 to T2.
Okay. No.
No,
Okay.
right? Because I have already mentioned this one, so therefore I didn't mention it because anyway it is T1 to T2. Okay. Right. So the serial schedule is equivalent serial schedule will be T3, T1, T2. Right. T3, T1, T2. Right. T3, T1, T2. And they mention what is the conflicting data is also. So here the conflicting data is Y, here the conflicting data is X. Okay. So you better mention that also because we never know, right? Maybe they are allocating marks for that also. They are not only mentioning this, they are mentioning what is the reason, right? You better do it because this is 2020 paper. So they have used that notation. So you better do it because otherwise we never know, examiner might expect in that also. That is the first time I saw that they have mentioned the data also. Okay. So correct serial or the equivalent serial schedule is T3, T1, T2. Right? T3, T1, T2. Next question. Consider the following two schedules, S3 and S4. Identify each schedule is allowed by two-phase locking and not by timestamp ordering protocol. Identify which schedule is allowed by two-phase locking but not by timestamp ordering. Identify which schedule is allowed by timestamp ordering but not by two-phase locking. Okay. Do it. Do it. Okay, we'll take a small break also. We'll be starting at 8:35. Okay. So do this also. Okay, let's continue. Right. So two-phase locking. Now this is they have given the timestamp. Why they have not given the locking? Okay. They say you have to draw the time table to justify, right? Okay. I thought why they are not giving that. Right. So let's draw the time locking table. This looks quite fussy question. So this is small one. Schedule 3. So schedule 3, let's do it. So this is read 1 next. this is transaction 1, transaction 2, and read to Y, write to Y, read 1Y. Okay. So if you go for locking, here transaction 1 will get the shared lock. Right. So here shared lock, I'm just writing here itself, but you have to write it in more details. So here shared X is taken by transaction 1. Transaction 1. Then shared transaction 2 take shared Y. Now transaction 2 take exclusive Y as well. Now exclusive Y is with transaction 2. So therefore, read Y cannot be done. It has to wait. Because read cannot be done when exclusive Y is in with some other transaction. So this one has to wait. So this one has to wait. So then of course, when this is committed, it will be released. Once it is released, you can take it again, right? Initially you can't, but after transaction 2 is done, committed, this lock will be released. Once it is released, you can do it. Okay. So what about this schedule 4? I'll write it here. There are 3 transactions. Transaction 1, transaction 2, transaction 3. Write 1x, write 2x, write 3x, write 1y, and write 2y. Okay. So exclusive lock is taken here. Exclusive X is taken by transaction 1. Now it is waiting for transaction 1 to release it. Okay. So we have only X, right? Now Y is there. Last 2 are Y. So this is waiting. Wait. This one is also waiting because the exclusive lock is taken by transaction 1. Right now, this guy can do it because Y is first time. Now it will be released. Once it is released, this guy will take the lock. And also Y lock is also released. So therefore, it can proceed. Then once this is done, this can proceed. Okay. But if you try to commit here, yes, you can't. I think what they mean is they try to commit here. They try to commit here. Now you can't commit because you have to wait until this guy commit. Okay. So this guy also cannot commit. And this guy also cannot commit because we have to wait until these guys commit. So maybe that is what they mean. But anyway, after waiting, both can be done. What is the answer? I don't know what is the question is. Question is a little bit fuzzy. S4 is allowed by timestamp but not by lock. Oh, S4 is not allowed by lock. Why? Maybe because of that they try to commit. Okay. S3 is allowed by locks. Yes, S3 is allowed by lock. Right? Allowed by lock because you can commit this. Because these are Y, then you commit this. Once you commit this, you release your Y, then you can proceed with the other one also. Right? So anyway, you have the exclusive lock. Here you release it after committing. So therefore now the lock is released. Once the lock is released, this guy can take it and this guy also can commit it. Right? But here the thing is you can't do as it is because you can't do commits here. You have to wait until this guy finish. So that is why they say you can't do it. Actually, it's not you can't do it. You can't do it as it is. So these guys has to go for waiting. Maybe that is what they mean. Okay. Right. So similarly, you have to double check with the read with the timestamps as well. Timestamps as well. So then take this is the starting time of the transaction one. Okay. This is the starting time of the transaction one. This is the starting time of the transaction two. Time two is the starting time of the transaction two. Okay. Right. So that you have to do because we did in the morning also timestamp thing. Okay. Right. Now I hope now you can do this question. Okay. Because we did a similar question last time. All right. It's also say deferred update. Yes. No, it says undo redo. Okay. Let's do this. Let's do this. So that this is not deferred update. So this is basically you have to do both undo and redo. Okay. Both undo and redo. Because the question says, consider the following transaction log from database system that is using undo redo logging with checkpoints for cache recovery, crash recovery. The log entries for the database are as follows. What are the values of the data item A, B, C, D, and E on disk after recovery if the system crashes just before line 11? Right? If just before line 11, this is where the crashing happens. Question is, what are the values of the A, B, C, D on disk after recovery? After recovery, do it. So that means forget about these things because it has crashed. Assume that no, these entries are not there. It has crashed at this point. Do it. What are the values of the ABCD? That is the question. Right? What are the values of ABCD? A, B, C, D, E. This one they say undo redo. So that means both steal and no force. Steal and no force. Let's assume steal and no force. Okay. But at the checkpoint, it flushed, but this is before checkpoint that this has happened, before checkpoint. Give it a try. The other thing is your exams are scheduled semester 135 March 19, right? I hope you don't have any semester 1 exam, right? So that means we can do some classes because this time I will be free because these days the other students are going for the exam. So this weekend I can take some sessions, but I will try to finish as fast as possible. There's another POE day or something also. I can take that day also. But anyway, your exams are semester 5 exams are here. So the semester 6 exams must be even after that. So they have not scheduled your semester 6 exams. Do you have any clue of semester 6 exam dates? Anyone?
They have scheduled it on April first week or second
April
week.
1st week, right? Right. So then anyway, yeah. So then we have another at least 1 week here also, right? Yeah. So then we don't have to worry, because here also I can take this week also. I assume that you don't have any semester 1 exams now. You are in the final year. Okay. Right. So then we will be okay. Okay. Right. Thank you. Right. So did you do this one? Right. So let's analyze this first. Transaction 1 has started. Then transaction 2 has started. Transaction 1 has committed. Transaction 2 has not committed. Transaction 3 has started. Okay. Transaction 3 has started. And this has crashed right here. So that means we have to undo transaction 2. T1 we have to redo in case of issues, but T2 we have to undo, T3 we have to undo. Okay, T3, T2 and T3, because they get commit later. At that point, we have no idea whether they have committed, they have finished or not. So therefore, we have to ignore or undo T2 and T3. Right. So, but T1 we can consider valid. So therefore, A 30 has become 50. 30 has become 50. Again, B 0 has become 40. Then transaction 2, let's not do it, because we have to undo this. Therefore, now we get the original value. Original value is 20. We are not going to change it to 60. Transaction 1 changing 50 to 80. So that is anyway we are going to take. Now transaction 1 is committed. But commit means yes, we are going to redo it anyway, commit, because we never know whether it has been flush or not, because it's undo redo situation. But that means still no false situation. Then transaction 3 start, but we are not going to do these things because it's crashed before that checkpoint. Okay. So that, but anyway, from this we can get a clue of D is originally 20. And E is originally 40. We are not going to do the change, right? We are not going to do the change when it is crashed here. So the final answer is 80, 40, 20, 20, 40. Let's see. 80, 40, 20, 20, 40, correct, right? 80, 40, 20, 20, 40. Right. So that is if it is crashed here. Now remember the idea is we are not going to consider the T2 and T3. If it is done, anyway, we are going to undo also. So therefore, we didn't consider these 3 activities. But from those activities, we managed to get the original values, because then the original values will be there. Okay. Right. So I hope you got it. So then what are the values of the data A, B, C, D, E, and F on disk after recovery if the system crashes just before line 80? Just before line 80. Just before, right? That means before committing transaction 4. Now let's analyze it again. Anyway, transaction 1 is committed. Therefore, we are going to redo it. Transaction 1 committed. Transaction 2 is also committed. Transaction 3 is also committed, that we are going to redo. Transaction 4 is not committed. So that means we are going to undo transaction 4 things. Or we are not going to do those things. Right? And that's it. Let's make sure T1, T2, T3 activities are done, but T4 activities are undone, because T4 is not yet committed before the crashing. Crashing එකේදී අපි දන්නේ නැහැ immediate ඊට පස්සේ committed හිටියද නැද්ද කියලා. ඒක පස්සෙන් වෙන්නේ. Right. So now let's do it. A is originally 30. 30 become 50. B is originally 0. 0 become 40. Correct. Then C 20 becomes 60. C 20 becomes 60. 20 becomes 60. Then A 50 become 80. 50 become 80. Okay. Now it's committed. Then T3 we are going to redo because it's committed. 20 becomes 70. D 20 becomes 70. E transaction 2 committed. E 40 becomes 60. Checkpoint, it will be flush. T2 is something committed. 60 become 90. 60 become 90. Transaction 4 we are not going to consider, right? But from that, at least we can know if original value is 10. But we are not going to consider that because T4 is not committed. Again, T4, we are not going to consider that. We are not going to consider that. But from that, we got the original value 10. Right. So the final values must be 80, 40, 90, 70, 60, 10. 80, 40, oh, different, right? 80, 40, 90, 70, 60, 10. Correct. 80, 40, 90, 70, 60, 10. 80, 40, 90, 70, 60, 10. Correct. Okay. Okay. Any questions on that? Any questions? That's it, right? Yeah, that's it. So that is 2020. So now we have done 2090 and 2020. අපි තව එකක් විතරක් කරමු 2000 අනිත් ඒවා question කරන්න ඕන නම් කියන්න. Right, so 2018 මේක explain කරන්න තියෙන්නේ. මේක නම් දැන් කරගන්න පුළුවන් වෙනවා. මම දැන් ආයි කරන්නේ නැහැ හරි. Precedence graph අඳිනවා. මම දැන් මේක කරන්නත් smart class එකේ. Consider the following schedule involving T1 and T2. මේක කරාද? මේක කරානේ. මේක කරා. මෙන්න මේකේ උත්තරවල ප්‍රශ්නයක් තියෙනවා. That is the final one, right? Yes, මේකේ උත්තරේ මොනාරි උඩපටයක් තියෙනවා. ටකල මේක කරන්න උත්තරේ වැරදි මං හිතන්නේ. Right. So that is our final question. So if you need me to do 17 and other things, just let me know. But otherwise I am not going to do because we are running out of time also. හරි මේක කරමු. හැබැයි මේක උත්තර වැරදි මං හිතන්නේ. උත්තර වැරදි හරි මොකක් හරි උඩපටයක් කරලා තියෙනවා. හරි. Consider the database log below at the time of system crash. What is the earliest possible LSN? I think LSN means log sequence number or something like. Okay, අපිට අද වැදගත් නැහැ මේ number එකනේ. Maybe log sequence number. Okay. Anyway, we don't care, just one number. By the earliest possible LSN read by the recovery manager. මේක නම් කරගන්න පුළුවන් වෙයි අපිට. අනිත් ඒ උත්තර පොඩාරි උඩපට. Right. So now let's see. So this is the checkpoint. Now it is not mentioned whether redo, undo or whatever. Let's assume it is undo, redo. Oh, because the question is not saying anything like that. Right? No. And it is not related to the previous one also. No relationship. So therefore, let's assume it's redo, undo. Okay. Otherwise, how can we do it? So this is your system crash. So what are the transactions? T1, T2, T3. Yeah, T1, T2, T3. Right? T1, T2, T3. So this is where the last checkpoint. Anyway, let's see. Transaction 1 is committed. That means we are going to redo. Transaction 2 and 3 are not committed. 2 and 3 are not committed. So they are not committed. But there's a checkpoint. At the checkpoint, usually you flush it. Right? Even uncommitted things are flush it. Because by default, it is steal. Steal, no force, right? So commit commit flush flush but therefore we have to undo this. We have to redo this, we have to undo this, okay? Or we can, in other words, we can ignore T2 and T3. But okay. So what is the last log entry that your LSN is going to read? So transaction 1 has committed, and also there's a checkpoint going. So therefore, that means definitely transaction 1 related things are committed, already done. We don't have to undo we don't have to redo those because its checkpoint is there. At the checkpoint anyway, transaction 1 related things are flushed. So therefore, we don't have to worry about transaction 1. This is where transaction 2 start. And transaction 2, we have to undo. So therefore, we have to start from LSN3. Because these two, we don't have to worry. We don't have to redo any transaction 1 related things because transaction 1 commit and also checkpoint. At the checkpoint, definitely the committed things are flush. So therefore, we don't have to worry. But transaction 2, we have to worry because we have to do undo. So I will say LSN3. At LSN3, that part is okay. But the next answers are the trouble. Identify the actions and how the values change during the recovery process. What is the value of X at the end of the recovery? Right. So this is permanent. So therefore, X will be initially 5 because transaction 1 is anyway committed and flush. Then transaction 2, we have to undo. So therefore, X is not, sorry, Y is not going to be 7. X is not going to be 9 because, sorry, Y will be 7 because it's transaction 1. So Y will be 7, that is fine. But transaction 2 is changing this 9 that we are not going to do. So therefore, my answer is X will be in the original 5 value because this transaction 2 is not committed. But it says checkpoint is done, but anyway, we have to undo it because transaction 2 is not committed. For me, transaction 1 is not doing anything else. So therefore, for me, X is 5, Y equals 7. And Z is, I don't know what is the original value is. So this is just the new value, but new value is 11. But here it doesn't show you the old values also. The old value pen new value pen. The old value here is it.
එතන අර start checkpoint කියලා තියෙන තැන line 9 එකේ T වරහන් ඇතුළේ T2 T3 තියෙන්නේ.
Oh.
ඇයි
ඒක තමයි මට තේරෙන්නේ නැත්තේ. ඒක තමයි මාත් මේ කියන්නේ. මට තේරෙන්නේ මොකක්ද ඒ කිව්වේ කියලා. මොකද මෙතන commit කරා කියලාත් නැහැනේ T2 T3. හරි. T2 T3 commit කරා කියලාත් නැහැ. मैं අදහස් කරේ commit කරා කියන එකක් දන්නේ නැහැ. එහෙම නැහැ. ඉතින් මෙතන commit කරා T1 කියලා වගේ කියන්න එපා. commit කරා T2 commit කරා T3 අනිත් එක commit කරා වෙන්න බෑනේ. මෙතන T2 T3 තව එක එක දේවල් කරනවානේ. මේ කියලා තියෙන commit කරා කියන්නේ මේ check point එක T3 T2 T3 ට check point කරා කියලා තියෙන. ඒ කියන්නේ එබැවින් flush කරන්න තියා. T2 T3 එකේ තියෙන data ටික flush කරන්න නැති. අර flush කරා කියන්නේ එකෙන් අපි අදහස් කරන්නේ නැහැ. මේක commit කරා කියලා. මොකද T2 T3 තාම ඉවර නැහැ. T2 T3 ඉවර නැහැ. අනිත් එක අහන්නේ final value of x නේ. End of the recovery. The end of the recovery final value of x එක 5 වෙන්න ඕන. මොකද මේ temporary values ටික ආය undo වෙන්න ඕන. flush උනත් undo කරන්න ඕන. මොකද මේක commit වෙච්ච transaction නෙමෙයි. So for me final value of x is 5. But examiner says final value of x is 9. Final value of x 9 කියන්නේ යා මෙන්න මේකත් අරගෙන තිනවා. මෙන්න මේක අරන් තියෙනවා. මේක අරන් තියෙනවා මේක අරන් නැහැ. හරි. ඒත් මට තේරෙන්නේ නැහැ කොහොමද ෆයිනල් වැලියු එක 9 උනේ කියලා because T2 is not committed. T2 is not committed. right? commit කරපු නැති එකක් කොහොමද ෆයිනල් වැලියු එක විදිහට ගන්නේ රිකවර් කරාට පස්සේ. I don't know. Because after checkpoint also some things are happening for the transaction too. And it has never said that it is committed. So I don't know. So for me, these answers are really confusing. And for me, it looks like the answers are wrong as well, but I don't know. Okay. For my best of understanding, it looks like the answers have some sort of a problem. Okay. So anyway, so I just wanted to do it because otherwise you will also get confused. I just want to show you that there is a confusion in this question. Okay. Right. Okay. So now we are moving to the distributed databases. Okay. Distributed databases because we want to do that also. Then next time when we are doing the database, we will be doing some questions on index as well. Okay, index, and also we have to do a little bit of query optimization as well. Query optimization also we have to do. Right. So let's start the distributed database. It's a very small topic, very easy topic. Okay. Right. So what is distributed database? So distributed database means your database is not in single place. Your database is in multiple sites. Right. So this is different from distributed application, where application is in different places and applications communicate with web services, etc. Okay. So that is the first thing I want to clarify. By the way, you have another subject, right? Middleware architecture පටන් ගත්තේ නැහැ නේ තාම. Is it semester 6? දුවමට එක subject එකක් තමයි දුන්නා. So we have to do that one also, right? Yes, we need some extra classes there. Middleware architecture will do some, we have to take some weekdays, right? So otherwise weekdays means mornings. Okay. Yeah, middleware architecture we have to do, right? Then we have to do the system and network administration as well. Okay, we have a lot to do. Okay. By the way, middleware architecture is optional subject. If you are really good in your e-business and other subjects, you don't have to worry. But anyway, I'll be doing it. Okay. Right. So the difference between distributed database and distributed application is, in distributed applications, you have the application in different sites and they communicate with web services and other remote calls. Okay, remote calls. So that is distributed application. Distributed database means your database is distributed in different sites. And database is distributed and database to database is synchronized. There's a connection between database, not through web services and other things. This is application to application communication. This is database to database communication with the help of the DBMS. With the help of the database management system. So that we have distributed database management systems. Oracle has a distributed version. I think the Microsoft SQL also has. So then you can have your database in multiple sites. Some tables here, some tables here, and they are connected together as well. And they can look like single database, but some tables are here, some tables are here, and some tables are duplicated, right? Some tables are duplicated and some tables are only in one site. So then when you are retrieving data, say from this site, you have to retrieve some data from this database, some data from this database, and maybe some data from your local database. And you have to take all those together and give it as the output. So therefore, remember, this is different from a distributed application where application level communication happens through web services and remote. Here, database level, the communication happens. Okay. So your application is application. When your application communicate with the database, actually this database is communicating with other database to get certain data. Database level. Okay. So that is what is meant by distributed database. Okay. So that is the first thing you have to understand. So we have the centralized database where database is in one location. We have the distributed database where your database is in multiple locations. Same database, same schema, but different tables are in different sites, and sometimes same tables copies are in different sites. Okay, so then we say we have a distributed database. And there are so many related concepts as well. So the difference between parallel database and distributed database is, so parallel database means machines are physically close to each other, like something like load balancing or something. So, okay. So there can be even shared memory, shared disk when it comes to parallel databases. Okay. Maybe you have one database, both are in the same computer, and even the memory is shared. But maybe two copies are there. So those are parallel database. Those are not distributed database. Distributed database means your database are in different sites, distinct sites. Okay. So there is no sharing. How can you share memory or processor when this is in Colombo and this is in London and this is in Tokyo? Right? So you can't share. Means you can't share memory or anything. You can share memory and anything if they are very close to each other. Those are in the sort of same machine. Right. So what is mean by parallel database? Right? Parallel database. So your parallel database can be either shared memory, or of course it has to be close to each other. You can share memory. That means both machines are having the common memory. We call it tightly coupled architecture. Or it can share the disk. So two machines, but they are having the common disk. Right? Common disk. So then we call it again parallel databases. Okay, shared disk. But our concern is not the parallel databases. Our concern is distributed databases. Shared nothing. So this is shared memory. Okay. So the memory is also shared. So this can access others' memory. You can see this database record can be in this memory or this memory or this memory. And this database content can be in this memory or this memory or this memory. That is shared memory architecture. So here memory is not shared, but shared disk. Right? Shared disk. So this is memory. This is processor. Now you can see that these disks are shared. So this machine also can access this disk or this disk or this disk. Just give 1 minute. Okay. Right. So this is the memory is shared. Here memory is not shared. For example, this machine cannot access this memory, but the disk is shared. Okay. So this is shared nothing. So your disk, your memory, your disk, your memory, your disk, your memory. But they are close together, right? Close together in the same site. Therefore, still it is parallel database. Okay. So that is parallel database, right? So what we are interested in is the shared nothing. Shared nothing at the same time, they are far away in different sites. That is distributed database. Distributed database. Okay. Right. So this is distributed database. So these are different sites, maybe USA, Canada, like France, and some other places. Okay. So truly distributed database, truly distributed. They are in different sites, right? And they are working together, right? So they looks like one database, though they are in different sites. So different parts are in different sites. Right. So when it comes to distributed database management system, there are different architectures again. Okay. So distribution, autonomy, heterogeneity. So those are some concepts we are interested. Okay. So distribution, how the data is physically distributed, autonomy, whether the individual sites have independence, right? So can I use this database independently here, or I can use only as a whole, right? So autonomy means we can use this database as part of the big database, as well as we can use it as a single database. So that is called autonomy. Heterogeneity means if all these databases are of the same type, say Oracle, then it is homogeneous distributed database. But there's a possibility that this database is Oracle, this is Microsoft SQL, and maybe again Microsoft SQL, the Oracle, etc. Though they are different technologies, still these databases act as one database as a logic. So then it's a heterogeneous distributed database. So those are more complicated because there are some mismatch in the technologies as well. Okay. Homogeneous distributed database, heterogeneous distributed database. Right. So database is always using client server architecture, right? Databases are client server. Database is the server. Others are clients which query data. So you can have single server, multiple clients. Single server, multiple client, or you can have multiple server, multiple client. So this is actually multiple server, multiple client. So most of the time it is multiple server, multiple client. Okay. So single server, multiple client means it's a centralized server. So this is decentralized server. It's not just one server. We have our server in different sites. Okay. Right. So this is how you look at the database, distributed database architecture. So this is actually peer-to-peer architecture. So this is not a something we go into details. Okay. So we are more interested about the general architecture. Okay, general architecture. Let's get back to the general architecture first. Right. So this one I already explained. So it can be either heterogeneous or homogeneous. So homogeneous means it is of same technology, same vendor. Heterogeneous means they are from different vendors. Okay. And homogeneous you can subdivide into autonomous and non-autonomous. Heterogeneous we can subdivide into federated and multi-database. And homogeneous means it's the same technology. All servers are identical software. If it is Oracle, everywhere Oracle. Okay. So those are less complicated because they are pretty high, 100% compatible because it's the same database management system. Right? Oracle and Oracle. Homogeneous distributed database. Now this is a distributed, yes, but I'm just looking whether they are heterogeneous. Database එක වර්ගය කියලා තියෙනවද මෙතන නෑ නේද? No, right. No. So this is just another examples given, okay? Right. So when it comes to homogeneous distributed databases, right, you can identify two types, autonomous and non-autonomous. Right? Autonomous means each database is independent. So they can act their own as well. Okay. They can collaborate at the same time, they can act independently as well. So then we say our database, homogeneous distributed database is autonomous. Non-autonomous means there's a central master database. Other sites are under the control of the main master. So then you don't have the autonomous. So that master site do the coordination. Okay, so then we say it's non-autonomous. Right, so this homogeneous, right, Oracle. So this is a heterogeneous example. So this one is Oracle 7, this is Oracle 8, and this is non-Oracle database like IBM DB2 or something like that. Right. So that is again distributed database, but heterogeneous distributed database management system. Okay. So at different sites may be having different operating systems and different database management systems. Okay. Right. So when it comes to heterogeneous, remember homogeneous we can subdivide into autonomous and non-autonomous. Can work independently, cannot work independently. There's a controlling site. Heterogeneous we can subdivide into federated and unfederated. It's a different classification. Okay. Federated means something like semi-autonomous. So that means they have some autonomy, freedom. That is why we call it federated. Okay. Unfederated means again we have central coordinating module. So your sites are under the central module. Okay. So using that module you have to access the distributed branches, sites. Okay. Unfederated. Federated can federal දෙනවා කියන්නේ නේද? පරාසවාදී federal වගේ ඒගොල්ලන්ට පුළුවන් තනියෙන් independently ඉන්න. නමුත් මෙයා හැමතිස්සෙම අර send එකේ coordination එකෙන් විතරයි access කරන්න පුළුවන්. ඔයාගේ heterogeneous system එක. Okay. Right. So this is very important diagram. How the 3-tier architecture work in database management systems. Okay. So In normal 3-tier architecture, we have 3 tiers, right? What are the 3 tiers? We have external tier, external or user tier, conceptual or logical tier, and physical or internal tier. Now, if you look at this one, you can see there's an internal tier, right? Conceptual tier. Then in the individual sites, you can have the external tiers, different external tiers as well. Okay. Or you can have, this is not necessarily a distributed site. You can have different external schemas for different users. Actually, this is not distributed database. This is for a centralized database. Okay. So different users look at it as different external schemas. So this is the distributed architecture. Okay. So we have local internal schema. You have the local conceptual schema for each site. Then global conceptual schema. Then external schema, multiple external schema. Now these can be in different sites. Of course, they are in different sites. So in your site, you have your own internal schema or physical schema and conceptual schema. But there's a global conceptual schema as well. The external schema is connected to this global conceptual schema. Okay. So that is the distributed database architecture. So if it is a multi-database management system, so multi means what? You have the autonomy. Autonomy is there. Okay. Autonomy can තනියෙන් වැඩ කරන්න පුළුවන් යාට. මෙතන තනියෙන් වැඩ කරන්න බෑ. මොකද මෙතන external schema නැහැ. You can see no external schema here to work independently. No. Your database is only accessed through global schema. Okay. But when it comes to autonomous, that is multi-DBMS, you have your local external schema as well. So that means you can use it independently as well. Like independently also you can use your database in each site, as well as you can look at it as a global schema as well. Okay. Right. So this is multi-DBMS. So you can use your tables and other things as a local database, as well as all of those can be look at it through the global schema and global conceptual schema and global external schema as well. So that is what is meant by multi-DBMS architecture. So you have the autonomous usage as well. Here there's no autonomous usage. Your database is exposed only through global conceptual schema and then external schema. Okay. Question topic. This is the easiest topic. Once you understand, no calculations, nothing. Right. So why do we like to have why do we need distributed databases? So actually we should have mentioned this at the very beginning. Why? Why do you want to keep our database in different sites rather than keeping everything in one site? Right.
If one database fails, we can access another.
That is not, yeah, that is also there, but it's more than that. So that is actually having duplicate databases. especially if in this kind of a situation, if this database is down, sometimes you can't use it at all unless you have some duplications. The main reason is not to, it is not the main reason actually. Okay, so the main reason is sometimes, right, your organizational need is such. When your organization is distributed, right, for example, if you take a supermarket, say Food City, now we have Food City supermarket all over the country. Okay, all over the country. So what is the best approach? All the supermarkets connect to a head office database, or the database is distributed. This database is distributed. So banks are everywhere, right? Every major town, say Nubegoda, Maharagama, everywhere, or in between also branches are there. So should we go for central database, or shall we let them have their own databases as well? And let those databases connected together. It depends. For something like bank, usually they prefer to go for centralized approach. But when it comes to something like a supermarket, they prefer to go for distributed. Okay. Because supermarket is more localized thing. Right? Bank එක නම් එක bank එකකින් අනිත් bank එකට සල්ලි හරි මාරු වෙනව නේද? මෙහෙන් සල්ලි දාන්නේ අනිත් bank එකෙන් ගන්නවා. හැබැයි supermarket එකේ එහෙම නැහැ. Supermarket එකේ ඒ branch එකේ stocks වෙනම ගන්න අපි. ඒ branch එකේ තියෙන discounts වගේ දේවල් එදාට තීරණය කරන්න. ඒ branch එකේ මේ එළවලු වල මිල නෙමෙයි අනිත් branch එකේ තියෙන්නේ. මොකද ඒ branch අනුව වෙනස් වෙනවා. quality එක වෙනස් වෙනවා. මිනිස්සුන්ගේ affordability එක නේද? කොළඹ 7 මිනිස්සුන් විකුණන ගානට විකුණන්න බෑනේ. ටිකක් දුර පළාතකට යනකොට එකම prices වලින්. So you need that flexibility. Right? You need that flexibility. You need so then we prefer to go for distributed database. Of course, we need that uniform view as well, so that the head office can generate some reports, etc. But at the same time, we need that flexibility as well. So therefore, it's all depends on the way you look at it. And also, when your data is close to you, while you are getting some data from other sites, if the frequently used data is close to you, it's faster, performance-wise also, because you don't have to always go to the head office or whatever. Most of the data is in your site. Okay. And also, when you have everything in one place, performance hit is also there. Performance issues, because every branch is connecting to that particular centralized database. So when it is load is shared in different sites, again, the performance hit is also less. Now you can see there are so many advantages. Okay. And scalability. So when you scale up, right, when you things are in different sites, it's easier for you, performance wise and security wise and everywhere. Okay, but there are some complications as well. When your database is in multiple places, always it's more complicated, because when you are querying, you have to get the data from one side, some other data from some other side, connect together, and sometimes it can make it slow as well, because you are getting data from one side and another set of data from another side, and you have to combine those data. So it depends on the way you look at it and your requirements. Sometimes it can make it faster, sometimes it can make it slower. And definitely there's additional complication as well when you go for distributed databases. Right? Distributed transaction handling, distributed query handling, and some security concerns. A lot of data is transmitted in the networks. So additional security and other performance concerns are also there. Complications are there. At the same time, the scalability is also there. Okay. So therefore, a lot of applications are now distributed. Okay. Either database level or application level. Right. So what are the advantages? So the number one is it naturally fit into your business needs, so organizational needs most of the time. And of course, you can give a bit of local autonomy as well as the global views, better availability. Because if the main database is down, still you can run it from your local database. Maybe limited functionalities. Right? Better performance because most of the data will be in your site. Most of the data will be in your site. So if it is not in your site, only you have to get it from there. Then supermarket එක inventory එක. ඔයාගේ inventory එක ඔයාගේ site එකේ තියාගත්තම ලේසි. එතන update වෙන ඔයා update කරන්නේ නැහැ නේ මේ මාතලේ food city එකේ තියෙන inventory එක. Right. Right. So when it comes to distributed database, we have to support distributed query processing, distributed transaction management, right? Security and other things. So those are going to make things a little bit more complicated as well. Okay. Replication management, because some data is duplicated, then we have to make sure that this data is synchronized. Right? Then if there's a crash, there's another issue because it is crashed in one site. Right, but other sites is working. So now we have to recover. Sometimes you have to use the data from other sites also to recover this site. Okay, security and other things. Okay, so additional complexity is there, additional cost is there because distributed databases are costlier than normal databases. Additional security concerns because the data is transmitted over the network. Maintaining integrity can be difficult because tables are in different sites, right? Things like cascade operations. And of course, the lack of skilled people who are aware of these concepts, distributed database. So it's less, we have less number of system administrators, database administrators who can handle distributed database systems because they need special skills and knowledge. Right. So from this point onward, we will be discussing next time because we did a session on morning also, right? Right. So next time we will be finishing this and we will be doing past paper questions as well. And you will find that the past paper questions are pretty much repeating, pretty much the same question. So pretty much the similar or same question is asked. Okay. Right. We finish, maybe it will take another 1 hour and we'll do the past paper questions. And we are not going to do the distributed query processing because first we have to do the normal query processing and come back to the distributed query optimization. Okay, so that part will be done after the query processing is done. Okay, so then we have to do for some questions on query indexes and query processing, and we have to do the triggers and stored procedures. So triggered and stored procedures won't take much time. Most probably we will be able to do it in 1 day. Okay, right. So then database 2 subject will be over. So then we will be concentrating on more the system and network administration, and we have to do the middleware architecture as well. Middleware, right? So definitely we are going to have extra class on the POA day. I think second or third week. But before that, I am going to have another extra class on a weekday. But that POA day, you are not going to have any issue because if you are working, it will be a holiday. But other day, I have no option because Saturday, Sunday, I don't have any free slots. I have to do a morning session, maybe another 4-hour session, 9 to 12 or 9 to 1. Okay. I will let you know. I will try to do it earlier rather than make it late. Okay. Most probably, if not next week, it will be week following. Okay. Right. So that we can, maybe we can do the middleware architecture and do it maybe half of that. Okay. because it's a technical subject. Okay, it's a technical subject. Right, we stop at this point.